There we go. Okay, let me take a look. Let's see what we got. Who did that one? You need two diagrams. Excellent. This one looks good. You need two diagrams, the neutral and the charge. That one is a little confused. That one looks good. That one's looking. You need two diagrams. Hold it. You did the same one as them. They finished the first. You have to take a different one. Go for bromine. Is it silicone? Excellent. You got to do the second diagram. I'll charge. So back to this here, right? Because usually that one has to be charged. It does not fulfill. No, but for where's phosphorus? Gases. Oh, you got to label these things. Well, no, this one. Oh, this looks good. This is so phosphorus is 15. Instead of 2, 8. What is that? Right, like it's 20, but then it also has. I don't think phosphorus has 7 electrons in its outer shell. No? So why is it 20.2? How many electrons do you have? No. How many protons is more than one type of 50. So the one with that's not an should also have 50. Oh, if you did the ion, then how many should it have in that shell? Yeah, well, that means that there's some neon that would be 20. Right? And there's some that wouldn't be 20. Okay. Okay. Rapid fire. Rapid fire. Let's go. Right. So okay, your attention. Got everybody? Except for people who are writing. Person in the group who didn't draw this, explain. Oh. No, I don't have everybody over there. Wait. Okay, explain. Who? Who did? Explain.
Well, it has normal.
Did you draw it?
Yeah.
Okay, your partner has to explain it.
Oh.
Ha
Yeah. I don't know. I kind of forgot this from last year.
Oh, so this is why I get the person who didn't draw it to explain, because I want to make sure you guys are talking. So when you draw new things, make sure if you're not the one drawing, you're walking them through it, or they're walking you through it, and you're talking. So I'm just going to ask you questions then. Do you know which one of these is the neutral one? That one. So this is neutral. It has no charge. One of the things that you get in your periodic table that you're not going to, this would be a good time to mention that, is that I have given you a data table, and this data table looks beautiful. It has 2 periodic tables in it, because I want you to be prepped for Chem 11 if you decide to take it, because of course chemistry is the only science you should ever take. It's the central science and the science upon which all other sciences are based. And because the one you're given in grade 9, I find often confuses students when they get to this level of chemistry. So this is the periodic table you'll get next year. I like it because it takes away all the stuff. And if you know the patterns, you can just fill it in with the stuff on your own. It also doesn't lie to you. This periodic table has more stuff. And it's a little nicer to work with because it has the common stuff. But it also lies to you. And the reason I say it lies to you is that I notice some students will say, well, this thing is always +2. No, it's not. This is the charge it will likely go to if it goes to a charge. But it's not always +2. Something has to happen with the electrons first. It has to gain an electron. So it has to walk up to somewhere and someone and say, hey, how you doing? And then it will get an electron, and then and only then will it be -1. And so that's how we get all of those ones. But normally, if it's just chilling by itself, it hasn't reacted yet, and it hasn't met a partner, and it hasn't got an electron, it's 0, it has no charge. This is the chlorine ion. This is the chlorine in chlorine gas. But the chlorine in table salt is the chloride ion. As soon as we put a minus charge on it, we call it an ide. It's gained an electron. It's a little different. It's less reactive. It's got its electrons. It's a little happier. It's not going to kill you. It's just going to make your food taste better. The other part is that you're going to learn about naming and Roman numerals, which you did a bit last year. And I noticed some students who go, oh, I don't know, okay, it's either +2 or +4. And that's so wrong. Iron can be +2 or +3. That is the most common ones. But it can also be +1. It can be +4. And on rare occasions, iron will be +6. It's never +5, except for the couple of indications in which it is. So it leaves off a ton of information, gives you the false impression that this is all everything can be. Sometimes if you use this one, you'll go, oh, it must be +2, which is a mistake you wouldn't be doing if you use that one because you just go by the name. So I've given you both to help you transition. We'll talk about where this one is great and where the other one's great. And if you have a periodic table, you're like, I can't find tungsten. You go here, this is a periodic table. It's just in alphabetical order. And that's a completely useless thing for the periodic table to be, except for the fact that all of you learned your alphabet. So you can just go, oh, tungsten is number 74, because you can follow an alphabet, and then go back to the periodic table and go, oh, if its proton number is 74, then it must be right there. So the alphabet, well, if you can't find an element, just use the alphabetical order. That's the only reason that's there. So you actually have 3 periodic tables in this one. Next year, you only have that one, and to be honest, it's all you'll need. You'll be fine. Okay, this one, person who didn't draw. What do you got?
Pretty much the top one is the neutral part, and the bottom one's the No, it's other way around.
Oh, it's the other way around. What charge is it?
Pardon?
Which one's the charge and by how much?
The bottom one's charged by 2. No. Yeah. Yes.
Yes?
The top one
By
is
the-
charged -2.
This one's -2 and this one's +2?
No.
No.
The other one's neutral. The bottom
You know, this one's neutral,
yeah.
and that one is -2.
No.
Is it a -2? I feel, okay, here's a life lesson. If someone asks you a question, you say -2. And if they go, are you sure? What do you say?
Yes. No.
Yes. You say yes.
Yes.
You say yes, and they go, no, look, it's actually this. And you go, no, I said it was -2, and I know it's -2. It is -2. And the reason for that is because they've done studies on this. They put people in groups, and they have a ringer, 2 ringers in every group. Both of them vie to become the leader. The person who is most confident it'll be sort of made to happen where they vote, and they think they're voting, but they actually elect. Everybody will automatically, because the game is rigged, the most confident person who's a ringer will get elected the leader. And then they'll give them a series of tasks, and they'll be wrong for 3 tasks in a row. And then the 4th time is the actual part of the experiment. They have to elect a new leader. And the other ringer gives them the plan that will work, and the leader that they've had who's been wrong 3 times will confidently give them the plan that was wrong.
I'm a billion% sure that is correct.
Excellent. The person who tentatively gives the plan that is correct but has no confidence is almost never elected as the leader. People will believe a wrong person as long as they're confident about it every single time. If you are just confident, you can become president someday. You don't even have to be an American citizen to become president. Because according to everybody I've read, apparently Obama wasn't even born in the United States. So, I don't know. So confidently it's -2. You're still wrong. This is +2.
Nah.
Yeah. Because this one, how many electrons are here? 20. So they're balanced. 20 protons, 20 electrons, they're equal. If you had a teeter-totter, they'd be on either side. If you had a teeter-totter here, I don't know why I put an A, that's a teeter-totter. We got 20 protons, and we got 10 plus 8, we got 18 electrons. Electrons are negative. We have fewer of those. I don't know why I wrote a 1. I'm just trying to indicate we have fewer of those. More of those, that'll go down. Bigger, +2, bigger by 2. So remember the electrons are negative.
I have a hard time like that.
This one's nicely designed and indicated. We've got the extra electron on there, -1. That one is argon. Oh, decided to double down and pick the noble gas that I explicitly said not to, but also clever. Phosphorus ion, because we've got 288. Which group did, oh, and then we got basic phosphorus. What charge is this one? -3. Excellent. And that one, we got silicone, +4. Now, I'm really glad they picked silicone, because we could add 4 or we could take away 4. Which is easier to do? You could add. And it would be, what charge, if you added them, what charge would it be? -4.
Because it's a negative
But-
and a negative minus a negative.
Could you not also take away 4?
Yeah, I guess. but-
Yeah, you could. Right at that middle spot, it actually can do both. They can go both ways. They have twice the chance of a date on a Saturday night. They can do whatever they want to do. So if their partner is someone, another atom that wants electrons, they can be like, here, have all my electrons. I can give you 4. If their partner is someone who wants to get rid of electrons, they can say, give me all your electrons. They can be whatever you want them to be. So silicon sitting right in the middle is useful. We've got sulfur. Oh, excellent, we fixed it. We've got 6 down there for the neutral. We've got -2 and 288. Excellent.
Can you run anything? Yeah, you have to explain.
So, rapid fire review of grade 9. We'll do it in a little bit of notes. Heads up, I'm going to go get a worksheet in a moment, but you have a quiz nearly every week in a long block. Because I don't like giving them on short blocks. It uses up too much time. So today, you do not have a quiz. So when would you have the quiz?
Tomorrow.
No. Wednesday.
Wednesday.
No, it's 4 o'clock.
I leave the rest as an exercise to those who paid attention to what I said.
It's on Thursday. No.
I like how absolutely nobody knows what it is.
It is Friday. No, it's on Thursday.
On the,
Sunday.
It's not. No, it's not.
okay.
No, it's not. It's on Sunday.
He's being confident and wrong, which is exactly what I told him to be. Yeah.
Listening to the instructions.
Okay. Everybody has their notes out. They've turned to the correct page. I'm going to turn to this page. I believe we finished everything else up to here. Also, for those who weren't here, who said, well, we weren't here, where could you have gone to find out what we did?
We're playing football.
YouTube channel.
Where could you have gone to find out what we did?
There's a little classroom in your YouTube channel.
Yeah, I have a whole YouTube channel. You just go there and you can review it.
Yeah, but isn't it like a live stream so that?
Yeah, it's a live stream, which means it's recorded, and then it's available after class. Yeah. The entire purpose of that is because I don't actually expect that people during their sport will be watching the live. Although if you do that, I did have a student in English Lit. This is for Chemistry 12. Take a video of themselves doing chemistry homework, and I gave them extra effort marks for that. They had a higher learning skills. I did tell their English teacher, who then lowered their learning skills in English because everything has to balance out. It's called equilibrium. But you deserve more if you do that. If you hurt yourself in another class to do better in this class, you deserve credit. Okay, This is a review of everything from grade 9. The nucleus is the tiny dense part. You have shells and energy. We haven't specifically, although we mentioned it in class, this is also, I just want to mention, this is a bit of a lie. It goes 2, 8, 8. What's the next number? 18.
32.
18 again, then 32, I think. Although maybe I should count it through.
32, 18.
Yep.
8.
Oh, no, not 32 and then 18.
No, it's 2, 8, 18, 18, 32, 32.
Yeah, and then theoretically even more.
Let me start one.
If you forget what order those numbers are in, how many elements are in the first row?
2,
How many in the second row?
8,
How many in the next row?
8,
How many in the next row?
16, 18.
18. And then here, because we can't fit a periodic table, that 58 goes right there. It goes 55, 56, 57, 58, and it goes up. So here it becomes 32. We're not going to probably ask you beyond this anyway. So you don't have to go beyond 2, 8, 8, 18, 18. However, I am going to say it's a bit of a lie. You'll see textbooks that say it's 2, 8, 18. And they're correct. It's because the 10 jump down in terms of their energy because of quantum. And we do it in chemistry 11. So if you see it, don't be panicked. It's true. It's just
No, we're doing
they are there, but they decide not to be. So for the Bohr model, we go 2, 8, 8, 18. You had a question?
Oh, my question was why does it take those forms?
Because quantum.
Yeah, that's my thing.
I will actually hold on to it, and if we get to the end in a little bit, I can show you on the board in terms of energy patterns. It has I mean, you can ask why forever, and then eventually get to the point where we say you don't know. But there is a really good reason for it. Okay, so this is just a review of everything we've done. You've got a review sheet there. So let's start off. We've already done all that because I started you off. Oh, there's a quiz. Do the quiz. While you're doing the quiz, I took attendance on my phone, but I have to put it officially in my school. Otherwise, people get angry. We are. Timmy?
Yeah.
You're here? Thank you for coming to class.
I'm not supposed to.
Oh no, you are now.
I did this all of last year too.
I think your sports coach. Are you going to the junior boy soccer ISAs today?
No, we had that last week.
Yeah, I think they put it in wrong. So don't worry, I've just fixed it, so you can skip no classes. Oh, and that is true of literally almost everybody in this list. It's listing a ton of you as away. I'm going to go grab that photocopy I mentioned. As soon as I come back, I'll start asking random people for answers on the quiz.
I don't get my phone at night. Count them now. What's 9 plus 8?
Adam X. But 9 plus 8 is what? Yes.
Honestly, I was going to get that phone.
Electron.
It's just because it's
Oh my god, did you bang grade on science as well?
For the second one, for this one.
I never learned this stuff.
The second question, Adam, why?
Why didn't they just ship it?
Oh, that's, yes.
Someone's phone is on the floor. Put it away. Okay. Adam X has a mass number of 17. Zachary.
True.
True.
And then, can I see the next one too?
Oh, no. Now, how did we get that? Here's Adam X. 9 plus 8.
That's not how I got it.
No? How'd you get it?
That's probably how I got it.
Fair. Matthew.
I was guessing.
Atomic Adam X has an atomic number of 8. True or false?
False.
False. Hugo. Adam X has 9 electrons. True or false? True. One of the reasons we know is because that's an atom. If it had a different number, it would say ion instead. Timmy. Atom Y has 8 neutrons. True or false? True. Five, Kieran. Atom Y has 17 protons. True or false? False. Atom X and Y are the same element. Please say here. False. Question, gentlemen? No. If it's said with confidence, it must be true. Any objections? Yes?
I heavily
No. There was a hand. Yeah. You think they're the same. So now we have someone who says that it's true. How do we know whether it's true or false? What would tell us whether or not it is?
Just one person has
Yes?
You look at the paper and then you use your brain.
I believe that is a true statement, but that would be true for any problem. How would we know two atoms are the same specifically?
Because 8 and like 9 plus 8 add up to 17, and then 9 take away 17 is 8.
Right, so we know they both have the same number of neutrons. There is a key subatomic particle, yes?
Number of protons?
Number of protons. So we need to have the number of protons as the same. So therefore, this one is in fact true, because they are the same. You can have two elements in which their mass numbers are the same, and you can even have two different elements where their number of neutrons are the same. Their mass numbers wouldn't be the same in those cases, though. But if that happens, it doesn't. You've got to check the number of protons.
What element even is it?
Oh, what element? Bonus question. Look up on your periodic table what element it is. I'm about to ask somebody. 5, 4, 3, 2, 1, 0. Don't say it out loud. You're also wrong. Zoe,
Chloride?
how many protons does it have? 9. So what element? Why are we picking? Oh! Okay. Chloride looks like this, right? Chloride, and you have Cl, and it goes 35.5, and then it has a little box. But 17 is the mass number. So which one of those should then...
Oh.
This is equivalent to that one. So it's not this one. Which one is it? It's fluorine right above it.
It's fluoride.
This
Fluorine.
fluorine. Fluorine. So right above it with fluorine, because fluorine has 9 protons, and this has an atomic number of 9. Okay? By the way, really important point, fluorine is not spelled flowerine, but with the U first. It's fluorine. And I spent 2 years taking second year inorganic chemistry and third year inorganic chemistry with the world premier fluorine chemist at University of Victoria. He knows more about fluorine chemistry than anyone. And he said if we ever saw it that we misspelled it, that he didn't say that he would give us a 0. Actually, what he said is, I will look up your address on the registrar of students. I will break into your apartment at 3 a.m. and hold a knife to your throat, and then I'll ask you how to spell it. And if you say the flower, I'm going to lean down. I'm not going to do that. But I am going to say that I was trained by him, and I notice it a lot. Okay, moving on to a little lighter note. University can be wild. The person who worked next to me brought her rat to class, almost every class in second year. It was awesome.
Sounds pretty good.
While she was taking notes, her little rat would come out her lower sleeve, turn around, and like it would crawl out, and we'd pet it, and then it would go back into her sleeve, and then we'd continue doing notes. It's fantastic. It was awesome. Okay, isotopes. Isotopes. Isotopes are the same element. They have the same number of protons, but they differ in the number of N. What are N's? Neutrons. Like Jimmy. Jimmy Neutron. Now, this is what an isotope is. It's a bit like you order the identical car, but you have different styling options on it that will weigh a different amount but will perform the same. Or it's like you have identical triplets, but they each have a different diet and weigh the same amount. But because they're triplets, they of course have exactly the same memories and the same personality. Why is your laptop open? All laptops away. We're using sheets. You don't need the digital devices out. Put them into your bag. Just put it away. Put it away. Put it away. Okay. This particular notation is isotopic symbol. If we have X to the N, what you looking for? Oh, the garbages. No worries. This number up here is the mass number. And that is the element symbol. So for hydrogen 1, how many neutrons does it have?
0.
1.
0.
I've heard 3 numbers now in various levels of confidence. For hydrogen 1, how many neutrons does it have?
0.
Okay, we're going to start. Hands up when I get to the number that you want. So, number of neutrons for hydrogen, -2. No, do not put up. Okay, you need to know this about joke answers. High school, a teacher put down a thing. What are the various lords called in a medieval town? It was social studies, I didn't pay attention. One of the choices was Darth Vader. So I, of course, picked that and wrote a little answer about Darth Vader because I thought it was funny. The teacher put it, and it was funny. No, the teacher's putting that so you know not to pick it. And I actually lost a lot of marks. And I ended up getting only 85% in the class, which in the province of British Columbia means I missed my A by 1%. If I just gotten that one question right, I'd have had an A in social studies. probably would have taken history in university, and now I'd be teaching history now. And I would hate that because I don't like history. So probably a good thing I did that. Yes. Can you what?
So,
Oh, what are the rules about going to the bathroom?
Do you ask what?
Just don't ask. Just go. Oh, yeah. Okay. So answer -2. Nobody put up your hand. -1. 0. 1. 2. There was people who. You put it up twice. You can't vote twice. Voting twice in an election is illegal. I really like that election. I voted early and I voted often. What is the mass number? No, not the number. What? How do you calculate it? Number of what plus number of what?
The protons plus neutrons.
Number of protons plus number of neutrons. How many protons does hydrogen have? 1. So if it has a mass number 1, how many neutrons must it have? None. So that is hydrogen.
What? How, what?
no, it's secretly, hydrogen has 2 protons and it's -1 neutron.
No, stop that. Stop that because no, never mind. That'll be too much of a. There is a secret element that may exist that's only made of neutrons. Element 0. Anyway, so if it weighs 1, it has no neutrons.
1 what?
1. No, we did this last day.
It's like the, I forgot what it's called.
All the way back.
Atomic mass.
Atomic mass unit. There you go.
What?
Just wait until I. No, never mind. So, how many neutrons does hydrogen 2 have? As a group, everybody. How many neutrons does hydrogen 2 have? 1. And hydrogen 3?
2.
Excellent. This is the World War II story. So, in World War II, there was 2 groups, of course. Well, maybe more than 2. But the Germans were looking to build the atomic bomb, and so were the Allies. I'm going to draw very badly on the board. As I mentioned before, I'm not good at social studies. Up until about 15 years ago, I thought Norway and Korea were next to each other. Because that's where all the peninsulas and stuff are. So here's Europe and Russia, North America, UK, South America, and like Africa, and Australia, and don't forget about New Zealand. There's India,
That's way too big.
and
We need Asia.
Philippines. Oh, and Asia.
I forgot.
Japan.
Massive.
New
Okay.
Zealand's too big.
Here in Norway, the Nazis actually took over Norway. They were under occupation and they were doing the research. They needed, and the Allies, of course, are doing their research. And they need to know, or they want to know, where are the Nazis doing the research? Because if we can figure that out, maybe we can disrupt them. So they knew from their own research, this was used as radioactive shielding. Because it's water, H2O, so they would make water. If you use regular water, this is regular hydrogen. Not that good at shielding. If you make water with hydrogen 2, you got that extra neutron in there. The nucleus is twice as dense. You can then use that as liquid shielding. You pump it in, you pump it out. They would also be using tritium for H2O and have really dense shieldings called heavy water. Really incredibly rare, because those are incredibly rare isotopes. But they knew that the Nazis were probably also using it. So they started taking all their submarines and ships worldwide. They said, wherever you go, take a sample out of the water. And they found one area where they reported high concentrations, whole micromolar amounts. Still small, but much higher than you would expect from leakages there. Up in Norway, so now I'm going to expand this. This is all of Norway. I had to think about it for a second. And there's like rivers, and there's a dam, and there's a hydroelectric power plant. And they figured, well, if we're finding all of these heavy hydrogen, these particular isotopes in this, they're probably coming down the stream. And they look up the stream, and sure enough, there's a hydroelectric dam that would provide plenty of power it's secure. It's made out of a ton of concrete, so they knew that they could probably fortify it. And they're probably doing their research there. Doing it in Germany while things are going on, a little dangerous. Out here in Norway, never going to be suspected. So they flew in an allied parachute team. They all fell it. They went down, they parachuted in, and you could only access the facilities from this side of the river. They actually landed on the wrong side. So all the allies found a cave and starved to death. It was vitally important. First part of the mission, destroy the dam. You cannot just destroy the dam, do not get caught, because then they know we're coming. So there's a nearby town. They didn't go to the town, because then they would be found out. Even if they tried to hide them, they couldn't take the risk. They had literally just found a cave and died. So they sent in a second team. Most of them landed on the correct side of the river. They moved up, found the dam, blew up the facilities, and then escaped. And that is one, there's a few reasons, and that is one of the reasons why the atomic bomb in World War II had a differing in terms of who invented it first. We slowed the I wasn't involved at all. I had no part of it. In fact, with the name Neufeld, you probably think definitely not. But because it was blown up, the Allies were able to develop it first. And they used it, the power of isotopes. Because this one is common. These ones are very rare. And this is why when you look at hydrogen on my periodic table, it says 1.0079. Most hydrogen is hydrogen 1. But a very tiny percentage is hydrogen 2 and hydrogen 3. And that gives us, when you average it all together, the 0.0079. Okay, isotope name, the isotopic naming convention is that we would say hydrogen 1, hydrogen 2, hydrogen 3, where these are the mass numbers. Calculate the number of neutrons for these two uraniums. Does anybody know which one of those uraniums is the dangerous kind?
235.
235. This is the one you build bombs out of. This is the one. Yeah, Oppenheimer's come out, so everybody now knows it a little bit more. If you take depleted uranium, that's all the 235 has been taken out of it, it is a nice, dense, heavy metal. They've made ship keels out of it. So you want to get a world-class racing boat. You want that keel to be as narrow as possible, but also as heavy as possible. Make a very narrow keel out of heavy uranium. You also use it in the military, I think, for shells, because it's so dense it can go through steel. And so they'll make the shells out of them. Depleted uranium on the battlefield also gives you heavy metal toxicity, and it's one of the things that we are shaking our fingers at. You go into an area, you shoot off these shells, and now people in there have to deal with this environmental mess for a long time. Yep. Oh, you were scratching. I thought your hand was up. Go, Matthew.
I have 238 decomposing underneath our house. We have to have special filters and all that. Yeah.
Oh,
it's a
so
whole system.
you do not have just, you'll have a tiny amount of 235 as well. And is it radon gas?
Yeah.
Yeah.
So we have to filter
So
that.
this is actually quite common. There was a gentleman who worked for the national laboratories in the United States, and one day walking into the lab, he set off the radiation alarm. National laboratories is where they work with radioisotopes. And because he set off the alarms walking in, the alarm is there so that if you walk out and it goes off, you contaminated yourself with deadly radioactive isotope and you didn't know, let's try and help you. But he set it off walking in, which means he was probably a spy and he was doing bad things. So they, whisked him aside, what's going on? And they found out his home had so much radon gas coming through that he was getting exposed to X-rays after X-rays of radiation every single day. They had to pump the radon gas out, and his lower levels of his homes was actually like quantitatively radioactive. Most of the time it's just the gas, just the radon gas. There's radon gas detectors. If this is something that happens in your area, then you have to make sure you have good circulation to make sure it's not accumulating, because radon gas will just sit there and it's a very heavy gas.
Yeah.
So it just sits in the bottom of your base. It doesn't flow out. It doesn't fly away like helium would. What do you guys have in to deal with it?
I can't remember exactly what it is, but I remember they put something down there, so it's basically a negative pressure
Okay.
side.
So there's a spot for it to accumulate, and then they
Yeah.
pump that out.
Yeah.
That makes sense. Alejandra, number of neutrons in uranium-238.
146.
146. And Felix in uranium-235. Zachary, what are you doing? No. That was a rhetorical question. Where's Felix? 143?
33.
What? I think you might want to re-examine that. It has to be 3 less than this one because 38 to 35, and 235 minus roughly 100. Yeah, you got that. 143. There you go. This is why in a nuclear program we've a group did this as an exercise, how hard it is to make a nuclear bomb. They took a recent high school graduate, said, we're going to give you a summer job. We want you to design a nuclear bomb. And they're like, okay, you are not allowed to use any resources other than a public library and whatever you can find on the internet. And they're like, okay. And they got paid, and they then submitted their bomb designs to the national laboratories, same people in the United States that deal with radioactive isotopes. They also do their watchdogs for inspecting nuclear bombs that are sitting in their silos and for inspecting nuclear power plants. And they were like, yeah, that would totally work. It's really easy to build a nuclear bomb. You just need enough 235. And by enough, I mean you need slightly less than what's going to go off on its own. And then you take another amount of 235 that when together would make it go off. And then you just clap them together and it will go off. Now, the faster you clap it together and the more it fuses, the bigger the bang you'll get. But they used to do something called twisting the dragon's tail, where they would have uranium-235, and they want the amount just under the amount to make it go off. So they'd have 2 spoons, and they would scoop some in the middle with each hand from either side. Both sides is too little. And when it started to sizzle and get a little warm, they would just take out 1 scoop and then fold it up and then package it, put it on the belt, it would go away, and they do it again. They're getting like this close to fissible. One day, one of the first people to die of radioactive poisoning was doing this, and he accidentally dropped his spoon and couldn't take the amount out. It started to go off. If it went off, that's not a very good bomb because it's all loose and powder. It would have just destroyed their entire facilities as opposed to the city. So he went like this and spread the powder with his body and got it spread apart, but it had gone off enough. He got a lethal dose of radiation, and it essentially sterilized all his bones, so he couldn't make any more red blood cells, white blood cells, or anything like that. One of the first people to die of radiation poisoning. It was called twisting the dragon's tail, because you're just getting so close. The hard part is if you want to separate these two, they are chemically identical. This uranium will react with chemicals the same as this uranium. What is the only difference between them?
The weight.
The weight. And is it very much?
No.
No, it's a tiny bit. So what you do is you put them in a centrifuge and you spin them. And the heavy ones go to the outside, and the light ones go to the inside. But because it's such a light difference, and we're talking about bits of metal, they have to spin very fast, and it's a very complex machine. There's an entire computer virus called the Sputnik virus that they think was released by either the CIA or the Israelis. Its only job is to infect your computer and determine whether or not you are a centrifuge for that type of centrifuge. And if you are, and you're located in Iran, it messes it up. Not so it stops working, but so it doesn't work very well. And that's apparently its only job. Someone released this in a while, so Iran couldn't develop nuclear weapons. Yep.
Can you just shake it?
Really hard, really fast. Not like this, no.
Yeah, but if you just have something that vibrates, and it just vibrates.
Because of the slight difference, it has to go really fast. They actually dissolve it as well. You do a bunch of things with it. Yeah. It's not quite as easy as just shaking. It's not like gold panning. We're going to do a little bit of this. 1 second. I'll get your question. I just want to make sure I hand this up. Yes?
What's a centrifuge?
Oh, a centrifuge. Oh, I should bring one up. It is a device that spins. It just spins really fast. And what it will do, you ever seen on a playground those things that just sort of spin you around and you get pulled to one side? They do that. So you use a centrifuge. You know how people pan for gold in like a river? So the heavy stuff stays at the bottom. They'll do that with like stuff in a test tube, and all the really heavy stuff will go to the bottom. So we'll take like, if we're doing a blood sample, I'll take your blood, put it in a test tube, and spin the test tube really fast, and then all the red blood cells will go to the bottom, all the liquid goes to the top, and then we can separate.
Is this for
We have one, but it's actually really dangerous. It was built before safety standards, or just for testing. And so it's deadly to bring it out because it doesn't have a cover. Oh, you got one? How does it work? Oh, you have an in. Now,
We have to do this.
oh, who is anybody friends with the William who's not here or in his house?
We're not in town.
But your friend, you'll see him.
Eventually, maybe.
What house is he in? Anybody else in here knows? Could you give it to him?
I think it was an Ellis kid right after.
Pardon?
I think it was one from Ellis right after.
But he's in it, so. Okay, so for this is not due next day. What I would like you to try is number 1, 2, 3, and 4. If you remember last year, like 5 is easy, do 5. We are going to practice a version of 5 first. Because this stuff is going to become the basis of your quizzes, and we're going to go into a bit more detail. So 1, 2, 3, and 4 do for sure. This, when I take it in, will be formative. Your quiz will be summative. And if you know what you're doing, you can keep going. There's other stuff in here we've done today you probably confused. But 1, 2, 3, and 4 for sure. I don't want you to all do it once. Any questions? Excellent. I still have 30 seconds.
No,
You can start working. What do you know?
I already in my watch.
It's 1 o'clock now. Curse you and your accurate tells of time.
What is the test?
What day is the test?
Yeah.
Friday. I got more to cover on Wednesday before I give you the quiz.
Thank you, Mr.
And it's not a test.
Thank you.
It's an in-class assignment that's timed in which you're not allowed to use your book.
So it's a test.
No.
Do you get marked on
Seems
it?
like a test.
Yes, some of them. Yeah.
This seems
Who do I get?
very
Anything
quick.
else? K or something?
William K?
William K, okay.
Yeah.
Thank you.
You're welcome.